each system of equations by substitution. Now it's important to know a solution to a system of linear equations in two variables is an ordered pair that satisfies both equations in the system. So we're going to start by solving for one of the variables. So let's start by solving for y since it's already isolated. We're going to label our equations, equation 1, equation 2 to keep it organized. And we're going to rewrite equation 2. Y equals 3x is what we're going to use to substitute into equation 1. So equation 1, y is written as x plus y equals 4. And instead of the variable y, we're going to rewrite that as 3x. So we have x plus 3x equals 4. And now we're going to solve for x. First, we combine like terms. X plus 3x equals 4x. And 4x equals 4. To get x by itself, we're going to move this 4 to the opposite side of the equal sign. And to do that, we do the opposite operation. 4x means 4 times x. So now we've got to divide by 4 on both sides. And we're left with x equals 1. Now we're going to substitute that into equation 2. We're going to rewrite equation 2. Well, actually, let's do, equation 2. We're going to rewrite equation 2 as y equals 3x. And we know that x is equal to 1. So we're going to notate that here with our semicolon. X equals 1. We just solve for it. This is where we get that from. X equals 1. So instead of x, we're going to put the number 1. So we have y equals 3 times 1. We're going to get y equals 3. So our solution, or our system of ordered pair, is 1 and 3. And we check that by substituting it in for equation 1, which is x plus y equals 4. And we know that x is 1. We're going to put 1 plus, instead of y, we're going to put what y is. Y is 3 equals 4. And we do know that 1 plus 3 is 4, so this is correct. That's true. 1 plus 3 is 4 equals 4. Further evidence. Let's go to our next one. X plus 3y equals 8. First, let's label our equations. Equation 1 and equation 2 to keep our work organized. Since equation 2 is already isolated to just one variable on the equal side, we're going to use that to substitute into equation 1. So let's rewrite equation 1. X plus 3y equals 8. Instead of y, we're going to put the expression 2x minus 9. So we rewrite the entire equation But instead of y, we write 2x minus 9. We'll finish writing out the equation as it's written. It's 8. And then we use PEMDAS to solve for x. So first we have to do parentheses, and here we do the distributive property. So 3 times 2x is 6x, and positive 3 times negative 9 is negative 27. We'll bring everything else down. Now we combine like terms. 6x, x plus 6x is 7x. Bring everything else down. Minus 27 equals 8. Then we add 27 on both sides. Now we get 7x equals 35. Then we divide by 7 on both sides. And 7 goes into 35 5 times. So x equals 5. So if we just use equation 1, let's look at equation 2. Y equals 2x minus 9. In which x is equal to 5. So now we rewrite our equation, and instead of the variable x, we're going to put the number 5. So it's 2 times 5 minus 9. 2 times 5 is 10. And 10 minus 9 is 1. So y equals 1. So the solution here, or the ordered pair for this system of equations, is 5 and 1. Let's check it. We can use equation 1 to check it, or 2, it doesn't matter. X plus 3y equals 8. Instead of x, we're going to put the number 5. Instead of y, we're going to put the number 1. 3 times 1. We already see it's correct. 5 plus 3 times 1 is 8. It's 5 plus 3. Then it comes down to 8 here. Let's do the next one here. 5x plus 2y equals 0. X minus 3y equals 0. So let's label our equations to keep our work organized. We're going to isolate equation 2. 2 is x minus 3y equals 0. We add 3y to both sides. X, these two cancel. And we're left with x equals 3y. Okay. And now we're going to plug that into equation 1. Five x plus 2y equals 0. And instead of x, we're going to put the expression 3y. So 5 times 3y plus 2y equals 0. Now 5 plus 3 times 3y is 15y. Plus 2y equals 0. And 15y plus 2y is 17y. So 17y equals 0. And divide by 17 on both sides. Y equals 0. These 17s cancel out. All right, now let's plug that into our equation 2. Which is x minus 3y equals 0. And we know that y is equal to 0. We just solved for it. So we're going to write that as x minus 3 times 0 equals 0. And 3 times 0 is 0, so now we have x minus 0 equals 0. And we know that comes to just simply x equals 0. So our solution is 0, 0. Let's do the next one. X equals 4y minus 2. X equals 6y plus 8. Let's see what happens here. Organize our note taking. First equation, second equation. This is x equals 6y plus 8. We're going to plug that into the first equation. So equation 1, x equals 4y minus 2. And instead of x, we're going to put 6y plus 8. And this is equation 1 we're substituting into. Subtract 4y from both sides. We want to get all the variables on one side and the constants on the other. These two cancel out. 6y minus 4y is 2y. and bring everything else down. Plus 8 equals -2. Let's subtract by 8 on both sides. That cancels. -2 minus 8 equals -10. Bring everything else down to y equals -10. Then we divide by 2 on both sides. Those 2's cancel. We get y equals -5. Now we can plug that into equation 2, which is x plus 6y. X equals 6y plus 8 where y is -5 with our semicolon. So then we have x equals 6 times -5 plus 8 . 6 times -5 is -30. Bring everything else down. And -30 plus 8 is -22. So x equals -22. That's our answer, -22 and -5. We can check that and plug that into one of our equations. Let's plug it into equation 1, which is x equals 4y minus 2 . We said x is -22 and y is -5. So alright, so -22 equals 4 times -5 is -20 minus 2. Got this from there. And -22 is equal to -20 minus 2, and -20 minus 2 is -22. This is also correct. Great job, everybody.